inheritance. So inheritance is one of the OOP principles, okay? And today we will see why it's important, how to do inheritance, and few rules and examples when it comes to this concept. Okay, so to talk about inheritance, let's start with an example and we will go from there. So imagine I have a class, for example, uh, um, rectangle. Okay, so in rectangle, I have something like, for example, let's say double x. Okay, you know, a rectangle, you have x and y. Okay, the width and height. But let's say we call them x and y. Okay, and we have some functions, for example, get area. Okay, what is the, how do we calculate the area of a rectangle?
Multiply x and y.
Yeah, it's the result of y and x production. So something like, okay. Now, if I have another class, okay, it's called square. Okay. So in the square, what do you have? You also have x, okay, and you have y, but x and y in a square are equal to each other, right? Because it's a square. So you only care about the length of uh, one side in the square. You can also have something like, okay, and you can go from here for a triangle, for example, you can go. But the important thing is that you will notice, okay, if you are still writing, I'll let you finish. Okay, just finish this example.
Mohammed, we don't have to put the parameters in the get area like x, y, and
No,
x at the bottom.
no, you have like, you have the x of the square, so you don't need to pass it another time. Like You already have it in the class. Okay. We can add another function called draw, for example. Sorry, not double. This is a void. Something like I am. Okay, so this one, for example, will draw a. Imagine that this code will draw a rectangle in the first one, and it will draw a square in the other one. So you will notice that we're repeating a lot of stuff, and even the concept, like the width and the height, okay, yeah, the get area, the draw. You will notice a lot of similarities in those two classes, okay, either in the functionalities or the properties, okay. Now the problem, if you want to, for example, draw something here or in the main function, if you are creating a shape, okay, now the main issue is that you need, for example, a special function in the main for the square, okay, special function for the rectangle, okay, because your main can see those similarities between those classes. Like anything you want to do in the main, okay, it needs to be repeated 2 times. One, like even if you are just creating a shape, you are trying to calculate the area, you are trying to draw it, okay, your class program won't be able to see those similarities. Like it doesn't matter how similar those two classes to you, like the code won't be able to spot any differences, and you need any similarities, sorry, and you need to repeat the same code over and over, no matter how similar those two classes are. You will notice that you are also repeating code. Like you will notice that a lot of this code is somehow similar to this one, and you are not like getting advantage of like the shared stuff. So when it comes to inheritance, okay, we can create a parent class that contains the shared things between all the child classes. So we can say that we have a class called shape. Okay. Now in the shapes I'm talking about, I have, for example, something like, you can call it width or X. Okay. I have also Y. Okay. And I can share those shared properties. Like maybe you have lots of properties, like imagine you have 100 properties, okay? So you don't need to repeat them here and repeat them here, okay? So you can say, okay, I will remove them from the child classes, and I will let my classes inherit from the class shape. Inherit means you can use all the public and protected stuff from this class. Okay. So let's take a look at the code. Like you will notice that I removed the X and Y in the rectangle, but I don't have any error. Can you imagine why? Like like look at class rectangle. I'm saying return X and Y, although I don't have any X and Y here.
Because you inherited it, you said, from the shape class.
Because I am inheriting them from the class shape. Okay, So the class shape, my parent, okay, my base class has X and Y. So when I am inheriting from it, then I have X and Y too. Of course, they need to be public or protected. If they are private, I can't inherit them. Okay, so now I was able to um, isolate the properties. So here, look at square. Square is complaining now that, oh, what is X? Because square is not inheriting from anything yet. So once square inherits from shape, now it has no problem recognizing the X because it inherited those properties from it. Of course, if you have one property, it doesn't make sense to, do all the inheritance thing and deal with all complications of inheritance. But we are supposing that we have lots of properties here. Okay, so please try it yourself and make sure it's working and you can see everything. Okay. Okay. Now, for example, imagine that drawing as well, okay, is somehow shared between most of the functions. So, like to draw, you need maybe to um, prepare your colors, prepare the algorithm that will draw the width and the height, and like most of the drawing is somehow similar between all the shapes, okay? But there are just some few differences. So I can write the shared part, okay? The shared part, I can write it in the parent. So for example, I can say something like public void draw, okay? You can use the same name. So here, write the shared drawing uh, drawing code between all the shapes. Okay, so like this should be like some kind of complicated algorithm. Okay, for simplicity now we are just uh, like just doing some bright lines. So here, okay, and here as I said, I isolated all the shared code for drawing in one function, okay? And now my child classes can extend this code. Of course, we will learn later that like there are better ways to do it with abstract, with virtual, with overriding. But for now, we will learn like the the basic thing, which is not the final thing that we usually use in production, but we don't want to go into the abstract matters now. So This one is saying you that it's hiding this function. Okay, that's fine. So this is the rectangle and it has its own draw. So you want to use the code that your parent has, then add your own extra code, right? So to do so, just call it with the word base. So what does that mean? That means I am a rectangle. I am trying to draw. Okay? Okay, that's nice. So what should I do here? I will call my parents draw to do all the shared part with the base keyword. Then I will do my like do any extra drawing in the rectangle. Okay, so I use what my parent has, okay, with the word base. Then I will do my part, okay, any extra part. Maybe I don't need any extra thing, then I don't need to write the whole draw. I will inherit draw as is. Okay, let's suppose that for drawing square, like I am just good with what my parent is offering. So let's create in the main, okay, let's create a square. Equals new square. Now notice that square, okay, this is the square, it doesn't have a function draw, okay, but I'm still able to call square dot draw. Why? Because my parent has a draw function. I am able to access the draw function through my parent because I'm inheriting from a class that has a draw function. Okay. Now I said I don't have any extra stuff to add to the draw function. Okay. So I don't even have to write anything in my square class. Like squares are nice. They are just uh, like they can live with what the parent is offering in his draw algorithm. But rectangles are more complicated, so they need to use what the parent has, then they need to add their extra stuff. Okay, so if you created a rectangle, so let's see the difference between both of them. So for the square, it just did what the parent has, which is this line. But for the rectangle, it was more complicated. It did what the parent has, okay? Then it did its own extra part, okay? So, but the thing here, like I was able to isolate the shared part between all the shapes and put it in the parent, right? That's the important thing. Now imagine if this is a complicated algorithm and a lot of code. Do you want to repeat the same chunk of code in maybe 10 classes? Like we learned that repeating the same piece of code over and over is extremely dangerous because if you found an error sometime, then you need to go fix it everywhere. Okay, it makes it easy, harder to test, harder to maintain. Okay, so you really want to isolate that shared part alone, and then if you are not happy with what your parent is offering, You can either write your own or you can use what your parent has and add your extra things. Okay? But if you are totally happy, like the square only used what's in the draw in the parent. It didn't have to use anything else. Okay?
Sorry, Mohammed.
Yeah.
Why didn't the square output the I am a square line?
I removed the function.
Oh, okay. I see.
Yeah. So I decided like squares are just easy to draw, and they are, for example, they only need the algorithm in the parent. So although now in the square class, I don't have any draw function, right? Like this is the draw class. It doesn't have X or Y or draw function or anything, but I'm still able to use them because
Okay.
it's inheriting from the shape class.
I see. Thanks.
Okay. So I just removed it to show that even if you don't have it at all, you can still have access to it. Now, what if I have, for example, let's see, that's okay. So I have a special field in the shape. Okay. So can I access this special uh, field in the rectangle or square? Like it's a special field in the shape class. Do you think I can access it in the rectangle, like in any place, like I did for X and Y? What do you think?
No,
Because,
it's private.
yeah, because it's private, okay, I can't see this field here. So if you tried, say, special field, you will notice that the autocomplete is not completing. Hi, I am the special field. And it will tell you that it's inaccessible. So this error, like the last line of this message, the pop-up, this is like one of the most famous errors. So every time you see the word inaccessible due to its protection level, that means there's something, okay, or something that needs to be public or protected or anything. Okay, so try to memorize or keep this one in mind. It happens all the time. Okay, you are creating a class. It's inaccessible due to that means it's like access modifier issue. Okay, so here we can't access this one. Okay, what if we move those to protected? So if those two, the X and the Y, they are protected, what is this going to change anything?
No.
Yes, it will change.
Yeah, so yes or no? Okay, Millie, why did you say, or why do you think it's...
Oh, no, sorry, comparing to public, it won't. Sorry, to
Yeah,
change
so-
private to protected. No, protected
Yeah,
are
so we
fine.
made it protected this time.
Yeah.
So anyone thinks it's going to change things?
You can overriding this?
No, we're not talking about overriding now. Like overriding is a totally different thing. But we just want to see what's the difference between public and protected. So why would I make anything protected or public? Like if they are the same thing and they don't change anything, why do you think I Why they made them?
Public is accessible from anywhere and protected just for the class and classes that are
Yeah,
inherited from that class.
right. So for you and your children, it doesn't matter. Like public is similar to protected. Now, the issue is in another class, as Millie said. For example, program. So program is a class. It's not inheriting from shape. It's like a foreigner to shape and his family rectangle. And so if you tried in the square, if you try to access x and y, so if you say something like square dot x equals 5, okay, now you will have this famous message: it's inaccessible due to its protection level. So you really need to know, like, those x and y, okay, shape x and y, like, are they supposed to be accessed from anywhere, from any class? If that's true, then you should make them what? Public. Okay, public means any class anywhere can say, okay, what is the x, what is the y, can I change them, can I read them? Okay, that's public. Now if you want to make this field x or y, or even a function, if you want to make it just a private thing for you and your children, you need to make it protected, so no one else from outside can access those two variables or the functions, for example. Okay, so that's the difference. So if you want it for you, just for you, okay, you need to make it private. If you want it for you and your children, you want to make it protected. If you want to make it for anyone, okay, so it's not like a secret and I want anyone to change it. Of course, you can put some conditions inside get and set, like the set, for example, if someone is trying to set the rectangle or the square x and y to a negative value, okay, for example, like this is not allowed, right? Like you can't say a square, the width of a square is -3. Okay, like it's impossible. Okay, so you can set some conditions, but it's still visible. Like, see, now this code is working. Okay, so now it's working because now it's accessible because it's public. So I really hope that now you know exactly what public, private, protected mean. Okay, and what is the default? Like if I, for example, removed it.
Public.
No, the default is not public. Like, do you think if you are making C#, do you think the default should be public? Like, let's imagine a house. So let's say that you didn't tell the house contractor if you want locks in your doors or if you don't. What do you think the default a contractor will do? Is he going to put locks on your doors or just keep them like free for all?
It should be static.
No. Why it should be static? Like, no, in terms of accessibility, like public, private. Okay, like think about, we always say that OOB should simulate real life. Okay, so in real life, okay, if you didn't say anything about your privacy, okay, about your house, your car, what do you think they will assume? They will assume, like people who are building those things, that you want the maximum amount of protection. Now, if you want to keep your door open, okay, for everyone, now when you say, okay, it's public, okay, so the default access modifier in C# is the least accessible one. It's the most protected or private thing. So here the default should be private. Because if the default is public, it's like you are saying, okay, the default is that everyone can access, which is dangerous, right? Because maybe you want to protect it. It's like saying that in Winnipeg, when they build houses, they don't install locks in any doors by default, unless you ask specifically for them. Okay, which doesn't make sense. Okay, so that's how we need to like imagine it, that the default, if you didn't write anything, is the least okay accessible one, and the least accessible one in a class is the private one. This is the least accessible.
I have a question.
Yeah.
Can you like declare it twice? Like, could you make a private one and a public one where like private? No. Okay.
Because like it doesn't matter if it's private or public. Declaring the same thing twice is not allowed, regardless of what is the accessibility in it. And like you really don't like it doesn't make sense like to have it twice. Like, okay, if you want it private and public, so which one is the one? Okay, is it and when you refer to X from somewhere else, are you referring to the private one or the public one? Okay, so it here, like in C#, it's not allowed to define anything twice. Not a function, not a variable, not a class. Okay, everything should be defined only one time. So when we talk about the default access modifier, it's the least accessible one. What is the default for classes?
Internal.
So classes has only two. We have internal and public. We don't have private classes in C#. Okay, so internal and public. Public is for everyone from anywhere. Internal from everyone in the same namespace. Only in the same, like see this namespace. Now, if you are in this namespace, then you can see the internal stuff. If now I just went and created another namespace and another project, I won't be able to see the internal things in this namespace. Okay, we will talk about namespaces and assemblies in more detail in the future. Okay, so please keep that in mind. It's not hard to know, but it's very hard to forget. Okay, but if you now understand what is the default thing, okay, now I'm pretty sure you won't forget what is public, what is private, but it's very common to forget what is the default thing in C#. Okay. So we talked about access modifiers. We saw that you can share a field with your children. You can share a function with your children. Okay. Now, when it comes to get area, for now, the only way to do it is to write it in each class. Okay. Because get area is different, like the calculation of get area is different in each class. Now, in the very near future, we will learn like, okay, what should we do when we have something like get area, which is different? Like we still can do stuff, but we won't see it today. Okay. Now, what if I want to create a list of shape, for example? So suppose that I want to create a list of shape. Okay. And like, it doesn't matter what shape, like there could be triangles, rectangles, squares. Okay. This is called shapes. Okay. And let's say, for example, I want to, for the square, let's write now a specific one, okay, or a specialized row in the square. Okay, so now both of my classes, both of them, they have a draw function. Okay, they will use what is the shared code in the parent, and then they will add their stuff. Okay, now imagine I wrote a function public void draw list of squares. So this one takes what? This one takes a list of squares. And it will perform for each, for example, var sq in squares and I will call sq.draw. Okay, so this is a function that draws a list of squares. Okay, now imagine I want also a function that draws a list of rectangles, a function that draws a list of triangles. Like, see, like I'm repeating a very similar code, but I am creating so many functions that first they are doing the same thing, and the code even is very like similar to each other in my main. Okay, so instead of doing this, like now see, for example, if I want a list of rectangles, okay, so this is just getting uglier and uglier. Okay, like now imagine if I have 10 classes. Okay, do I have to write 10 versions of each function I want? Now this is only for drawing. What if you want to get areas? What if you want to do, okay, so like you need 10 versions of each function in the main. Okay, so what if I just created a function, okay, that takes a list of shapes? So instead of those two, what if I created something like this? Draw a list of shapes, okay, and shapes here. It's called shape. Okay, let's see. Will I be
Might
able to?
also,
The list of
sorry, you might also want to change the squares into rectangle and
Oh,
shape.
sorry. Yeah. Yeah, that's what happens when you copy paste code. Okay. So now instead of having 10 versions of each function, I will have only one that takes a list of the parent thing. So like for drawing, a list of shapes, for for calculating the areas, for doing anything you want to do. Now you no longer need to write 10 versions or whatever the number of different stuff. You can only use the parent thing. Now let's try to see if it's working or not. So I have a square, I have rectangle, I have a list of shapes. Okay. So notice that what happened here, like in my shapes list, although it's a shapes list, I was able to add what? I was able to add a square. Although like this is a class, okay? But I was able to add stuff from my child classes to this list. Do you remember when we said the list is very strict? Like if you created a list of integers, you can't put doubles or strings, right? That's what we learned, okay? But although I created a list of shape, I was able to put stuff from different classes, okay? Which looks very weird for C Sharp. You know, C Sharp is very strict, okay? But C Sharp accepted that because square and rectangle are children of shape. Okay, now imagine like shape is your father. Okay, your father rented a house. So like usually when you rent a house, you are the only one who is supposed to stay in the house. But like the rules in real life that if you rented a house, then your children get to stay in the house. So if you have a list of shapes, then your children also get to stay in this list, although they are actually different classes. Okay? So this is something extremely important to notice when it comes to lists and generic types, that you can either put the parent or put any one of its children in the list. And now you can send them anywhere to any function. And it doesn't matter like how many types you have. And the beauty here is the same list now can contain so many things. Yeah, like rectangles, squares, they are different, right? But they can be contained in the same list. So imagine, for example, you are asking the user, can you draw some shapes? Then I will take all the shapes that you drew and maybe save them to something. Okay, so the user may draw a rectangle, they may draw a square, then a circle. You don't know what the user wants. Okay, now instead of creating a list for each type, what should you do? Create one list and put everything the user is drawing to one list, and now send it to printer, send it to like anything to do with it, anything, instead of creating like all kinds of lists, okay, and calling the functions one by one for each kind of list. Okay, so again, for the last time, we know that lists only accept one type, but if you are talking about inheritance, lists also will accept the the children type, okay, and it will put so many different things as long as they have the same father. Of course, the list should be of type shape, of the generic type. Now, if you created a list of square, then you can only put squares. Okay. Like if my brother rented a room, I don't get to stay in the room for free. But if my father did, then it's like for the whole family. Okay. Okay. Now I can send this list to the draw list of shapes, and I can send it there. Okay. Now let's see if this is going to show the specialized things or not. First, let's remove those guys. So notice what happened here. Like I created a list of shape. Okay, list of shapes. I inserted a square and a rectangle. And I was hoping that the specialized version of square.draw, rectangle.draw, they would be called. But instead, I only got what's in the shared shape class. Okay, look at the result here. It's saying drawing the shape, drawing the shape. It's not going to square class and rectangle class to take what's in there. Okay, that's something we will learn in the future, but I want to show you the difference. Okay, so what you actually want, like you have a list. Okay, you have a list of shapes, right? And you are throwing some squares, some rectangles, and then you are calling the draw function on each one of them. Now what's happening is, because the list is from shape, then it's only calling the shape draw. It's not going down there to the rectangles, to the squares. Okay, now in the next class, or like soon enough, we will learn how to, like, although for example I created a list of shape like this, we will learn how to go and call each one of the draw functions according to the type of the shape itself. Okay, for now we only have this like shared code. Okay, but we want to keep it for the future so we can exactly know what's the difference. Okay, now we achieved one thing, at least, that it's only one list. Okay, and I am able to do stuff, and I'm able to put any kind of it. That's like my first achievement. Now, my second thing that I was hoping to achieve is that, okay, each one of them, like when I'm calling a shape.draw, it will know the type of the shape, like is it a square, is it a rectangle, and it will go to the specific draw. But this didn't happen because, of course, we didn't do the overriding part, which what we will do in future class. Okay, now we only want to take a look at the main concept. Okay, so any questions about the main concepts? First, private, public, protected, sharing the variables with your children, sharing functions. Okay, your children can call what you have and they can add their own code. If you created a list of the parent, you can put anything from the children in it. Okay, as long as they have the same parent. Okay, and when you call, for now, when you call the draw function inside the list of shape, it will only call what's in the parent. It won't go down and call what's in the children. Okay, now this is as usual, like this is a new concept, so it's okay if you are feeling okay a little bit, is it ambiguous, is it hard, but at least we want to know why we're doing this. Now the how part is different for each language. Okay, for C#, for Java, for PHP, but the why is almost the same everywhere. Okay, so the why part is to share the properties and share the functions and share the code between multiple classes, and to be able to create lists that contain like a big set of different things. Okay, but they are similar in their like nature. Okay, so sharing the code and the reusability of the code is the main purpose of inheritance. Okay, the reusability. Okay, we'll take a break now, and then we will continue with the rules, and it will get a little bit harder, so get some more coffee or whatever. Okay, now what we care about is the concept. Okay, reusability. Now what we will learn now is mostly about syntax, about the rules, which is important, but not as much as it's important to know what's the purpose of the whole thing. Okay, so if you understood this part, This is extremely good. Okay, the next part should be a little bit harder, but it's like it's not as important as this one. Okay, yeah, see you very soon. Okay, so here this function is supposed to serve the whole type of shapes, regardless of creating objects, right? Like regardless of any object, it's not for a single shape itself. It's for like all the shapes. Do you remember when we said about static that it represents everything? And if you have a counter, if you have something that doesn't concern, like, you know, like a rectangle cares about its X and Y, about its area, okay? But when you have something that concerns everyone, then this is a static function. And this function, okay, you can't inherit it. Now, you can still call it from, for example, let's say something like here, you can say shape dot some static function. Okay, you can still call it from square. Okay, but you will notice that Visual Studio is telling you that, oh, that's not like the correct thing. I think you need something else. So if you asked your Visual Studio, okay, can you correct it for me? So you can still call it from square, for example, but it doesn't make sense. Like, why are you doing this? This is only for the parent. This is not something that we are inheriting or changing, okay? So when it comes to static stuff, they don't like inheritance. Okay. Now, let's talk about constructors. So I want to create a constructor in the shape. Okay. So public shape. Okay. So public shape, let's just in the shape, let's just try something like I am the shape constructor. Okay, and then in the square, for example, let's create another constructor for the square. I am the square constructor. Okay, and for now, let's leave the rectangle without anything. Okay, like the rectangle doesn't have any constructors. So here I created a square and I also created a rectangle. So when I created a square, I should do what's in the constructor, right? Because we said that the constructor is automatically called when you are creating an object. Okay, let's see, like I'm expecting to see this message because I created a square, okay? Now, let's see what happens. So I created a square and I'm expecting I am the square constructor, but I saw that I am the shape constructor before the square one, although I didn't create a shape. Now, when I created a rectangle, I also saw that I am the shape constructor message. So what's going on here? Like every time I'm creating a square or rectangle, I'm seeing this message. Okay, so let's try to follow the code. So I will put like a breakpoint here. Okay, like when we are about to make a square, And of course, I will put like a breakpoint on the shape constructor as well. Okay, so when I create a square, it should come here and stop, and then it will execute this one. Okay, let's take a look. So I'm creating a square. It should go to the square constructor, okay? But by default. Okay, what should I do now? Okay, let's go to the other step. Now I'm supposed to come here and write this message. So you will notice that it didn't go inside the square constructor. It went up to the what? To the shape constructor. And let's see what happens. It will start, or it will execute what's in the shape constructor, the parent. And okay, what's the next step? What should happen now? Then it will come back to the square constructor and it will execute what's inside it. So what do we learn from here? We will see that every time you create an object from a child class, it will call the constructor of the parent. Okay, by default. Like even like, well, you don't need to do anything. You don't need to call it. It will be called. And actually it's mandatory to be called. Okay, so you need to be careful that anytime you are creating a square, you are also creating a shape by default. Okay, you are calling the constructor of the parent, then you are, and the constructor of the parent is called first. Okay, now if your parent has a parent, it will go and call the like your grandfather constructor. You know, because it's like if I am class A inheriting from B, B is inheriting from C. Okay, so you can make a chain of inheritance, and the most like deep one, the most deep class will be called. Okay.
I have a question.
Yeah.
Might be nothing. Could you show us the result of that program again? Like how it's printed?
Sure. Oh yeah, we need to remove those. So it will, like, those two lines are new square. Like when I call the new square, those are two lines.
Oh, you
So-
called the square first. Also, okay, okay.
Yeah,
Because
I
I
called-
called the shape and square. My result was a little different printed. Okay, thank you.
Yeah, of course it will be different. Yeah, it depends on what you have. So I called the square first. So when I called the square, or I created a square, I saw the shape message, then the square message. Now, when I created a rectangle, like, you know, rectangle doesn't have any constructors. Like I didn't make any constructors in rectangle. But I saw, like, even if you don't have any constructors, your parent constructor will be called. Okay. Now,
Okay.
what if I have more than one constructor? Like this is square. Okay. Like what if square has another constructor that takes what? That takes the x, for example. Okay, so when you want to create a square, you will say, okay, I will initialize the length of the square, right? Okay. So you will say this dot x equals the x that I want to initialize with. Okay. That's like two different ways. Some people want to create a square without anything. Some people want to create a square and they want to send the length right away. Okay. So what is going to happen if I created one of those squares now? So if I created like a square, yeah, sorry, square. And I say it's like 10, the x. Okay. So it should come and go to this constructor. Okay. And it should print like a message. I am the square constructor with a parameter. Okay, so with the parameter, I'm the shape constructor. So is it still going to call the parent constructor? Okay, let's see. Okay, so this is I am the square constructor with a parameter, and it before it executed this constructor, it called what? It called the parent constructor. Okay, the constructor in the parent. So whether your constructor will have uh, um, like a parameter or not, it will still call the one in your parent. Okay. Oh. Okay. Okay. Now, what if you do you remember when we said that now if you don't have this one, okay, that's fine. So you don't have this one. Let's start. So I am the square constructor with a parameter. I am the square constructor. So we said that it's mandatory to call the constructor in the parent, right? But like, look at the parent. This is the parent, shape. Can you see any constructors in shape? This one is commented out, so it doesn't exist. Can you see any constructors in shape here, all this code? Okay, so, but we said it's mandatory to call your parent's constructor. So where is it? Like I don't have any constructors in the shape.
Well, by default, you have the default one.
Yeah. So do you remember when we said even if you didn't create any constructor, there is a default empty hidden one that's always there for you? Okay. So keep that in mind. Okay. So please note that we are trying to use our previous knowledge, okay, and build upon it. So it's very important that you guys are reviewing the previous classes. Soon it will be too much to review. Okay. So we said that you have this default hidden constructor that's always there for you. Okay, so this one, it will be called, of course, it will do nothing because it's empty, but it's mandatory that you need to call a constructor, and that's empty one will be that empty one will be the one. Okay, now do you remember when we said that sometimes if you wrote a constructor by yourself, you will disable the default hidden one? Okay, so what if I took shape? So this one takes integer x and sorry, not integer x. So double x, double y. Okay, so I want to create my shape. So when I want to create my shape, I want to say what are the x and y right away. Okay, it's my right. Okay, I want to construct a shape and say x and y's values right away. Okay, and like shape is happy. Like you will notice that no problems in shape. Okay, but what did you do here? Do you still have this empty hidden default constructor in the shape? Do you still have that default hidden one?
No.
Hello?
No.
What happens when you write any constructor in any class? You disable the default hidden one. Okay, that was there for you. It was doing its job. But when you write a constructor yourself, you will disable that one. Now, okay, now shape is still happy. Like shape will say, okay, I have one constructor that takes 2 parameters. I'm good. Now, the people or the things that are not good actually are the child classes. So let's take a look at rectangle. So rectangle is telling you, okay, when I want to create a rectangle, I'm supposed to call the default constructor in my parent. But you did something, which is you disabled the default constructor in my parent, and now I have no constructor to call. I have no idea what to do. Okay? So, you know, like it's very important to know why rectangle is complaining now. It's telling you I was used to call the default hidden constructor in the shape in my parent. But now, since you disabled it, okay, I have no constructor to call. I don't know what to do. And of course, it won't call this one by default. By default, it will only call the hidden one or the empty one that doesn't take any parameters. And now it's complaining that I have no idea what to do. Okay, so what should you do here is now you need to manually call the new constructor that you wrote in the shape. Okay, so now when you create a rectangle with, okay, this is the rectangle. Okay, now when you create it here, you need to call constructors, any constructor in the parent. Okay, and the only constructor in the parent needs what? Needs x and y. This is the only constructor in the parent. Okay, and you need to call a constructor in the parent. Of course, this is the only one that we have so far. So we need to call this one. So we'll say that rectangle, okay, it will do what the parent is doing. So the rectangle constructor will also take double x and double y, and it will call by using the keyword base. And this is how you call it. Okay, this is just syntax. It will call the constructor in the shape using those x and y that you will use. And now rectangle is happy. Now rectangle is saying, okay, when someone wants to create a rectangle, I will call this constructor in my parent. Now I know what to do. Okay, what about square here? So square has two constructors. Both of them, they need to call the constructor in the parent, right? Now, thanks to you, okay, you disabled the default one. Now, both of them have no idea what to do. Both of them, they don't have any idea how to call the parent constructor. So you need to call it manually. Okay. So here you will say that, okay, base. So this square is taking x, but the base, the one in the parent, it needs two values. So you can send x 2 times. So this is just calling the parent constructor. Parent constructor needs 2 doubles. Now send whatever you want, as long as it's 2 doubles, that's fine. Okay. And now this one, now here you need really to like think what to do. Like this one needs to call base 2. Okay, but what are the numbers you want to send when you create an empty? Like maybe you can send like 0 and 0. Sorry. Like whatever you want. Like when I create a square, like if I am, if I want to create a square with the default square constructor, what's going to happen? It will go here from here to this line. Now, this is the square constructor, right? It needs to call some constructor in the parent. Okay, that's what we agree on. Okay, the only constructor in the parent needs 2 numbers. So you can send whatever, like any 2 numbers you want. Okay, like when I create a square, it will be 0, 0. Okay, that's your choice. Okay, when I create a square with 10, with one number, it will come to this line, right? And it needs to call some constructor in the parent. So now I have x, which is like the number I'm passing to my square. I can send it the same number. I can send it to my parent's constructor. Okay, so the whole idea here, if you disabled the default constructor in the parent, the empty one, then you need to manually call the constructor in the children using the base keyword. Okay. So using the base keyword, you need to manually call any constructor. Now, if you have another one, like let's say that you have a shape, okay, that takes one double, just the x, like this constructor only initializes, sorry, here we need to say something like this dot x equals x, this dot y equals y. So here, like in this one, I want only to initialize the x. So this dot x equals x. Okay. So now I have two options. Now those guys, they can either call the one that takes one number, or they can call the one that takes two numbers. Okay. Now you have two constructors in the shape, right? So you can call either one of them. Okay, but of course you need to send something like this constructor in the parent is expecting a number, so you can't call it without sending a number, right? So here, for example, the square x, so I can either call the one that takes two x's, or I can call the constructor that takes one x, because this is a square, it only cares about x. While the rectangle is still it still wants x and y. Okay, so the whole idea, once you disable the default constructor, now you have to call the constructors yourself from the children, and it's your job to call them and to send the correct parameters. Okay, Roy, you were asking.
Yes. So I have a question, like just what if you just create a new constructor in shape, it just like empty
Yeah, well, yeah, if you want to create an empty one, now if you want everyone to be happy, you can create the empty one. Okay, now no one will complain. Like now, even if, for example, this guy is not using the base keyword, okay, it will call like if you don't use any base keyword now, all of like anyone that doesn't use a base keyword, it will call the empty one. I'm saying, what if it's not there? What if it's disabled and it's not there? Okay, now if you want to avoid all the trouble, okay, you can just, okay, you disabled this guy, okay, write it yourself then. Okay, so do you remember when we said when you write any constructor, you disable the default hidden one? Okay, write the default empty one yourself. And now no one will complain, because any child can by default access this one. So now you have, now this is of course like a better approach if you want to avoid compiler errors. Okay, but it's like you are doing nothing here. You are just calling the empty one. Okay?
Yeah. Thank you.
Yeah, you're welcome. Okay, so the only way to know what's going on here is to play with the constructors yourself, to do some debugging, like put a breakpoint here and see where is it going. Okay, now if I remove, like I'm in square now. Okay, see guys, I'm in square. If I remove this base keyword, is it like I didn't have any error now? Why? Like this constructor in the square is not complaining. Why it's not complaining? Like if it was complaining a moment ago, but now it's not complaining anymore. Although I removed the base keyword. Because we said this constructor wants to call some constructor in the parent, right? Square, this constructor in square needs to call some constructor in the parent, right? Okay, now it's not complaining, that means it knows which one to call. Okay, which one it's supposed to call? The default empty one. So if you have the default empty one, okay, no one will complain because they know that, okay, that's the one that we will call. Okay, now if you don't have this one in the parent, that's when constructors will start complaining. Oh, like, I don't know what to call in my parent. This one say, oh, I don't know what to call the parent. I need the base keyword. You need to tell me what to do. Okay. So what you need to do is to try it yourself. Try remove the default one, see what happens. Try to use the base keyword, see what happens. Keep in mind that all the constructors in the children, they need to know which constructor in the parent to call. So if the parent has the default empty one, they are good. They will call. If the parent doesn't have the empty one, you need to tell them yourself which constructor to use using the base keyword. Is it clear? Okay.
Yeah. I
So-
have a question.
Sure.
Usually when you say like this X or this Y, this name, the this is grayed out. But here
Yeah.
it's not grayed out anymore. Why is that?
Because like if the name of the parameter you are sending to the constructor equals or the same as the name of the field, you need this. You need the keyword this.
Oh, the case was different. Okay, thank you.
Yeah, if the case was different, then this is like not important. The keyword this. Okay, but if they are the same exact name, the variable and the field, then this is mandatory. Okay. Okay. So in our institute, if you remember, we had the student, we had the course classes. Okay. Now I want to start talking about the members, like staff. Okay. So I want to create like a class for teachers and a class for admins. And I want both of them to be from a class called staff. So let's write this down here. Create a new class, okay, teacher, and a new class called admins. Okay, you know, like at MITT, you mostly have either teachers, okay, or like administrators and student advisors. So let's call them admins. Okay. both are from staff class. So we have 3 new classes. Okay, we have staff, we have admins, we have teachers. Okay, and like everyone that works at MITT, they call them staff eventually. Like it doesn't matter if you are a teacher or an admin, you are eventually a staff. Okay, but for example, we have some shared stuff like the names, the date we joined, but like calculating the salary of a teacher is different than calculating the salary of an admin. Okay, while for example, printing, let's say printing the performance report of teachers is exactly the same as printing the performance report of admins. So like we have some shared stuff with admins, but we also have some special stuff for us as teachers. Okay, so I want to create a class staff, a class admin as class teacher, and create the relation between them. Okay, let's try to do that.
Are we just making the 3 classes and 2 are children of staff?
Yeah, so let's make the classes, and of course, let's put some fields like name, birthday, anything. And also, let's put some functions, like functions that you think are shared between staff and admin, and functions that you think would be different between staff and admin. Okay.
Okay.
Okay, so let's take a look at this thing. So what we're saying here is that we are creating teacher, admin, and we're creating staff. Okay, now in the staff there is a shared function. Okay, it's called get info. This one will display or print the name and the joining date of each staff member. Okay, and it's shared for everyone. That's why I want to put it in the staff. Now, all staff members, whether they are teachers or admins, they have what? They have a base salary property. Like, what is your base salary? Okay, so this is also something that's in the parent staff. Now, I'm telling you where they are supposed to be, but of course, in the future, you should know, like, okay, this is something that's in the parent or in the child. Okay, now I want to create a function called calculate salary to calculate the salary of my members. Now, for admins, they only get the base salary. Okay, like your base salary is 50K a year. Okay, that's what you get. But with teachers, they get a base salary, which is usually low for teachers, but they also take or get a salary for each hour they teach in their courses. Okay. So in the teacher also, we need a list of what?
Hours.
Sorry?
List of hours.
No, not list of hours. Close, but no. What do you mean by list of hours? We don't have a class called hour. So that in the teacher, you need a list of, like, well, I'm a teacher. Okay, I have a name, I have a birth date, I have, what do I have also in MITT?
What course you teach?
Yeah, like it's just like common sense. That's the nice thing about OB. So I also in my description in my object, I have a list of courses that I teach. Right. So the teachers, they have a list of courses that they teach. Do you have, for the admins, do you have a list of courses in the admin class? No, because they don't teach. So the list of courses that I teach, is this something that in my class or in my parent class? The list of courses.
Your
In
class.
teacher class.
In the parent?
No,
In the teacher.
No,
teacher.
only the teacher. Because if it's in the parent, that means everyone has it, including admins, and this doesn't make sense. Admins don't have a list of courses. Okay. So, and also I have a list of courses. So in the, like, each course has what? Has different hours. Like some courses are, for example, 60 hours. Some courses are 70 hours. And each course has a different, like, hourly rate. Some courses are like $30 an hour to teach. Some courses are $40 an hour to teach. So there are many changes that you need to do in the course class itself. Course class, that's the old one. So what should you add in the course class? Like, to be able to calculate the salary of a teacher, what should you add to the course class?
Number of hours that the teacher.
Number of hours this course is supposed to be, and the cost of teaching an hour. Like a course of math is maybe more expensive than a course of art, for example. Okay, so the course of math should say, okay, I am a course of math. I have 100 teaching hours, and the cost to teach 1 hour in math is $25. So there are changes you need to make in the course. So that's what we do all the time. Every time you learn something about the system, every time there's a feature required from you, there is a change or a set of changes that you need to do. Now I want to calculate the salary of a teacher. Okay, So I need a list of all courses this teacher is teaching, right? And for each course I am teaching, I need to know how many hours in this course, like, okay, what is the length and what is the cost to teach each hour. Then it's easy calculation. Okay, so of course I like helped so much in this one, but it's just we are just starting, so that's fine. But in the future, like I'll just give you the problem. Okay, like we need to calculate the salaries, so you need to know that. Okay, then a teacher, how do you know like uh, that how can you calculate the salary if you don't know the list of courses the teacher is teaching? So you will know that, oh, I need to create a list of courses in the teacher class. Okay, and I also need to know the number of hours for each class and the hourly rate. Or maybe you can like say like what do we have now in the course? Like in the course we have number of like we have duration. Okay, like duration, is this months or hours? Like it's your choice. You decide what is this. Okay, so now if it's in month, then you can add the cost for each month and calculate it. If this duration is hours, okay, then you say, okay, like duration is hours. That means the duration is, for example, for math is 100 hours, and the cost to teach each hour in math is $10. Okay, so what is the salary for a teacher who is teaching math if it's 100 hours and each hour is $10? What? Like I have a course math. It's 100 hours. Each hour is $10.
1,000.
Yeah.
When you ask a question that's too easy, we wonder, is there a trap in there?
Yeah, that's
Like,
the problem.
really?
Yeah. There's no constructors in this question. No. Okay, there's nothing. Okay, so that's the thing. But the thing is, always think like it's a recipe. You are calculating the salary of a teacher, right? It's like you are making a cake or a recipe of something. Okay, so you need to know, okay, to calculate the salary, I need to know, okay, all the courses you are teaching, the number of hours in each one, the cost for each hour. Okay, it's a recipe. Now I have everything. Now I can make my cake or whatever. Okay, okay, let's work on that. Now you know everything. Okay, just code it.
Can I see how sorry, the syntax again for where you refer to the parent? I'm just getting a weird error in mine.
Like which class exactly do you
Okay.
want?
Yeah, because for my class teacher staff, it says there's no argument given that corresponds to the required formal parameter. Get
Is
an
this
error.
like a construct? Like, can you share it with us?
Sure.
Okay, class teachers, staff. Okay, what do you have in staff? Well, teacher can't be the wrong thing. Yeah, so it's a constructor issue. See, like you created a constructor yourself. Okay, the constructor in line 318. Okay, so you disabled the default empty one, right? So now teachers complaining like, I don't have the default empty one. So if you want to solve all your issues, just create another staff constructor. So public staff, okay, and make it empty, like just parentheses first, and then it's empty. Okay, just close this one, okay? Now other classes shouldn't complain. Like now you have the default empty one and your children won't be confused. They will say, okay, we will call this one. Okay,
Okay.
now go back down, down there. Yeah,
Oh,
see,
thank
they
you.
are not complaining because they now have something to call, a constructor to call.
Okay.
Otherwise, you need to do it manually. Okay.
Thank you.
So to avoid the errors, always write this default empty one. Okay, so you like now have the peace of mind that I don't have any more compiler errors.
Thank you.
Okay, yeah, let's keep working on that. Just turn off my mic so it won't bother you. Okay, let me put it back in the questions. Okay, so like I'm trying to get closer and closer to the user story. So users, they will tell you their story. They have zero knowledge about inheritance, about classes. They will tell you, yeah, we have people working here. Some of them pay salaries, some of them, take for by the hour. Some of them are contracts, some of them are full-time. Okay, they will tell you their story and you need to translate it to a system, to OOB. That's like your main job. Okay, let's code this thing.
Salary in double or int?
Yeah, double would be fine. Okay, so apparently you are still working on it. Okay, that's fine. We will solve it together after the break. Okay, so we'll go through the answer step by step. And of course, before that, we will see like an answer or two from you, and hopefully we can see some mistakes. Okay, as usual. Yeah, so we can learn from them. We can see why this is wrong, why this is correct. Okay. Yeah. Anyone is almost there? Anyone is close?
Yeah,
Okay.
I'm done.
Okay. Yeah. So please next time just let me know when you are done, guys. Like I have no idea that you are done. Okay, but like try to relax now. Don't work in the break. Okay, just take it to relax, and we'll come back. We will do it together. Okay. Yeah. See you in an hour.